Hello, dear students. Let's start a new topic graphite. This topic from chapter 9 Carbon and its allotropes of class 8 in subject chemistry. So, let's open your chemistry book and come on the page number 131. 131. Now, concentrate on the topic graphite. So graphite is a grayish black colored substance. So generally graphites, the color of the graphite is grayish black. Now graphite is smooth and slippery to touch. So whenever if you go to touch the graphite, then it appears as a smooth and slippery during touch. Now the occurrence of graphites. So graphites generally occurs in the naturally graphites occurs in Sri Lanka, Mexico, Austria, North Korea, China and India. So the graphite occurs in the different countries. We can say that it is a worldwide distributed in the earth universe. Now graphites also occurs found in the India, in the different state of the India, such as Bihar, Odisha, Tamil Nadu, Rajasthan, Andhra Pradesh, Jammu and Kashmir. Now next topic, structure of graphite. So generally in the graphite, each carbon atom is bonded to 3 another carbon atom. So one atom of the carbon is bonded to the another 3 carbon atoms and form a hexagonal planar ring like structures. So this one, if you consider this carbon, so then this one carbon is attached with another 3 carbons. So these carbon form the 3 covalent bonds and one valence electron remains free in the case of graphite, and they form a hexagonal ring like structures, and many hexagonal ring like structure of the carbon are attached with the another hexagonal ring like structure of the plates, hexagonal plates, by a weak covalent van der Waals force. That's why the graphite having the slippery in nature, because the one ring of the graphite, one hexagonal ring of the graphite slides on the another hexagonal rings of the graphite in the graphite due to the weak van der Waals force between them. That's why graphite having the slippery in nature, and these carbons form a hexagonal planar rings. Let's see the diagram. So here the hexagonal planar rings, and at each corner the carbon atoms is present, and they form the hexagonal rings, and these hexagonal rings attached with another hexagonal rings by a weak van der Waals force. That's why the graphite having the slippery nature, because one this plates slides over the another plates of the hexagonal ring. Now these hexagonal planes are arranged one above the other give rise to a hexagonal layer structures. So this form a hexagonal layer structure, and this one is also the hexagonal layer structures. And the structure of graphite carbon atoms within a layer are bonded by a strong force of attraction. Hence, however, the carbon atom of one layer are bonded to carbon atom of another layer by weak force of attraction, and hence each layer can easily slide over the another layer. So now this one layer is bonded with the another layer by a weak van der Waals force, van der Waals bonding, so that this layer is slided over the this layer. So one layer slided over the another layer. This makes graphite soft and slippery. Hence, graphite is a good lubricating agent due to their slippery natures. Now, the preparation of graphite. Now, graphite can be prepared artificially by heating powdered coke with little amount of the sand and ferric oxide FeO. Coke heated in the presence of ferric oxide in an electric furnace to a temperature is approx 3000 degree Celsius. So when coke is heated in the presence of sand, silica or ferric oxide, silica and ferric oxide Fe2O3 ferric oxide. Let's see again. So when coke is heated, carbon is heated in the presence of silica SiO2 and ferric oxide Fe2O3, then it forms the graphite at 3000 degree Celsius, and that temperature is maintained by the electricity in electric furnaces. Then they form the graphite. Now next topic, properties of graphite. So graphite is a natural grayish black colored opaque and crystalline substance. So it is a grayish black color, opaque and crystalline substance in the nature. And next properties of the graphite is soft and slippery to touch and possess a metallic luster as like the metal. So this graphite is a carbon is a non-metal, but it possesses a metallic luster. Now graphite is the most stable allotropic form of carbon. Now graphite is the most allotropic form of the carbons. Now graphite is a good conductor of heat and electricity due to the presence of one free valence electron in the structure of the graphite, because only 3 valence electron of the carbon involved in the covalent bonding and 1 valence electron remains free, and that valence electron is able to conduct the heat and electricity of graphite. Now the density of graphite is 2.3 gram per centimeter cube. Now graphite having the high melting point and boiling point. Now when the graphite is burned in the presence of air at 300 degrees Celsius, then they form only carbon dioxide as the final product. It means that graphite contains only carbon, nothing to else. Now at high temperature and pressure, and in the presence of some catalyst, graphite changes into diamond. So in the presence of some catalyst at high temperature and pressure, graphite can be changes into diamond. But that diamond is not behave as a natural diamond, but some property of that diamond is behave as the natural diamonds, except their brilliance property. Now graphite is insoluble in any solvent, so it remain unaffected by acid and also the alkali. So graphite never react with acid and alkalis. Now next topic, the uses of graphite. So there are many uses of the graphite. Graphite is used in making the core of lead pencil. So in the lead pencil, the graphite can be used. At the tip of in the center, the graphite is used in the making the core of lead pencil. Now graphite is used as a lubricant in fast moving parts of machinery, and also the machinery which working at a high temperature, because graphite is resistance to the high temperature heat, because their boiling point and melting point is very high among all non-metals. Now when we draw across a paper, then graphite leaves a black mark on it. So graphite is used as a core of the pencil. Now next, graphite is used as a moderator in nuclear reactor to slow down the speed of neutron. So in the nuclear reactor plant, generally we can use the uranium as a radioactive element for the production of heat, and due to their productions they form to generate the electricity. So for the controlling of the radioactivities of the uranium by the slowing down of the speed of neutron, we can use the graphite which moderate the speed of neutrons by slowing down their speed of neutron. Now the next use, graphite is also used to make crucible for melting the metals. Crucible, it is a melting pot. It is used for the melting of the metals during extraction of metal. Next, graphite is used as electrode in batteries and electric furnaces in the extraction of the metal in the electric using the electric furnaces. Now the carbon brushes of the electric motor are made of graphite, because graphite is a good conductor of the electricity. Now the next topic. Now the activities. The aim of this activity is to demonstrate that graphite is a good conductor of electricity. This activity is very simple. You can also perform in the home. So first, the material required: graphite rod, battery, switch, bulb and insulated copper wire. Now the procedure. So first, we take a graphite rod and connect it to a battery, switch and bulb using an insulated copper wire to form a complete circuit. Let's see the diagram. So first you can take a a graphite rod. This one is the graphite rod, and connected with the battery, switch, bulb by using the insulated copper wire, and form a complete circuit. Now, whenever you turn on the switch, then the bulb will glow. Then we observe that the bulb will glow. Whenever we turn on the switch, then bulb will glow. Then we will observe that the bulb start to glowing. So bulb will glow. Then we concluded that the bulb glow because insulated copper wire of the conduction of electric current through the graphite rod. If graphite rod will not conduct the electricity, then bulb will not glow. But here the graphite rod conduct the electricity, and due to that the circuit is completed and bulb will finally glow. Then we concluded that graphite is a good conductor of the electricity. So it's proved that the graphite is a good conductor of electricity. Now the next topic, differences between diamond and graphite. So let's see the table. In the table, this one column for the diamonds and this one column for the properties of graphite. So diamond is a colorless and transparent in pure form in the nature, and graphite is a grayish black and opaque in pure form in the nature. Diamond, it has an octahedral structure. Graphite has a hexagonal structure. Diamond is the hardest occurring natural substance on this earth, but graphite is a soft and slippery to touch. Diamond is a bad conductor of heat and electricity, but graphite is a good conductor of heat and electricity. Whenever we burn the diamond in air at 900 degrees Celsius, is formed only carbon dioxide, and whenever we burn the graphite at about 700 degrees Celsius in the presence of air, it formed the carbon dioxide. Only the carbon dioxide. Next properties, its density is 3.5 gram per centimeter cube in the case of diamond, but the density of the diamond graphite is lesser than the diamonds. That is, its density is 2.3 gram per centimeter cube. Okay, this is all about the graphite, their occurrence, their preparation, their physical properties, and their uses, and the differences between diamond and graphite. Okay, thank you. Have a nice day.